All right, so this is Lab 5 for this course. We're going to be working with the Coriolis flow meter. It's a micro motion made by Rosemount. It's a Coriolis flow meter. It can determine mass flow. And you can see right now it is displaying a kilogram per minute value there. That's a mass flow rate. So we've got this set up here. We've got it plumbed in according to the P&ID in the lab. We have the pump coming out, goes over to the Coriolis flow meter, a ball valve on the discharge, and then it flows over to our tank here. And then from the bottom of the tank, we have a valve so we can drain the fluid back to the main tank where the pump is drawing from. So we're gonna do a volumetric proof on this again, but this time around we're gonna be, instead of figuring out the volume in this vessel here, we're gonna be figuring out the mass so we can compare it to the mass that the meter said, the mass of water that the meter says that is flowing through it. So to do that, we're gonna need to take a density measurement on our water as well. So what we'll do first is we're gonna get set up and ready to go for, get the meter configured and get it ready for doing this volumetric proof. So in the first part of the lab here, the first bit that we're gonna do, I'm gonna show you how to do, is programming the mass flow meter so it's displaying the units that we want and that we can reset the total from the totalizer and the meter factor. This meter factor we're going to be proving and verifying and then likely changing, but they need to be set to a value of 1 initially. So we're going to make sure that all these values are... So over here on the meter, to get into the menus, we need to hold down the scroll and select buttons. These are optical sensors here, or optical buttons. And then once the screen changes, we should be able to hit scroll and it should toggle to this offline maintenance. So we want to go to offline maintenance, hit select, and then we can hit scroll, hit select, and this is kind of just a verification that someone didn't accidentally push those buttons. So now we're into the menu here, and we should be able to scroll. The first menu that we want to go to is config here. And you can see right here, we're in the offline maintenance, and now we're going to the config, and we're going to check out, actually that's the main menu that we're going to be in. We're going to look at units, a submenu, display, and meter factor. So for our units, we'll go to that screen first. And what I'll probably do is just show you how to verify these, and we don't need to confirm them all. I'll do those offline, but I'll make sure that it's set up correctly here. Well, we'll see. I guess we'll see how long it takes first, but yeah, we'll go and get to that. So we'll scroll over, we'll hit select because we want to go into configure. There's units, we want to go into units. And our mass unit, let's see what that is. It should be in kilograms per minute. So it's in kilograms per minute. We don't hit select again and scroll over, check the volume. Liters per minute, that's what we wanted in. Hit select again, scroll over to density, and this should be in kilograms per meter cubed, which it is. And now I'll hit select again. So we verified all of our units. They were in liters per minute, kilograms per minute, and kilograms per meter cubed for density. Total reset, we want that enabled. So if we go back over here, we're gonna scroll over till we get to exit out of units. And we wanna find total reset. There's meter factor. Just check to see. Oh wait, we need to go out one more level. No, I think we were good actually. Config, and then display is where we need to go. That's what we were looking for. There's display. Reset, enter that. Show, hide. Yeah, we want it enabled, so show. Good. And now we're going to go back out to meter factor. Exit, display, need to find meter factor, and all the meter factors should be a value of 1. The mass meter factor is 1. Now to get out of this, we got to hold the 2 buttons down, let go. Volume, it's a value of 1. And density, it's a value 1. So all of these are good. So we're good to proceed now on to the next step. So I've exited back out to the main menu here, and we can scroll, we can see our mass flow right there. What we want to make sure is that our meter is displaying the total kilogram value here, because we're going to be comparing the total kilograms that have flowed through this meter to the kilograms of water that are in our tank here. And so we can set this value to 1 here if we just hit, or not to 1, sorry, to 0, clear it. If we hit select, scroll over, and then press select reset, and it's going to say, do you want to reset? We say select for yes, and there it's back, it's down to 0. So it's ready for doing our first run. All right, so I have the pump turned on here. I've got the valve on the bottom of the tank open. I'm just going to slowly open our valve on the downstream side of the Coriolis meter and just start filling up the vessel. And you can see we're reading mass flow right there. And just shut the valve on the bottom of the tank here, let that fill up a little bit, and then we'll shut this. And we should see this flow right there, it dropped right to 0, which is good. And we'll probably now have a mass value there. I'm just going to reset that. There, it's reset. You can exit. So now we're ready to do our first proof. So I'm going to record our start height here, which is 70. Let's say it's about 76 milliliters. We're going to start at 76 milliliters. We're going to fill this up, and we're going to record the mass that flowed through, and we're going to record the start and stop heights on a table on the whiteboard over here. All right, so we've got our table set up here, start, stop, and now instead of a pulse value, we have a mass value over there on the right. Recorded our first start value there at 76 millimeters, and we're ready to go over here. I'll just open the valve, and just downstream here, we'll open this quickly. So we have full flow, and you can see that it's recording a mass value there now, a total, and our liquid's rising in our vessel. So once it gets near the top here, I will slam the ball valve shut quickly and record our end value, or our stop value. So that's probably good right there. And there we've got our mass value. It's still kind of catching up. And we have, just gotta wait for this to kind of stabilize. 535, we have 535 millimeters. 535 millimeters, 6.9713 kilograms. So I'm gonna go ahead and record that. Just like we did with the other meter, we're gonna have to make sure that we reset this value. So I'm gonna make sure you have it recorded first. So that's reset. And now I can drain my tank and get ready to do another run. All right, there you can see our values that we just recorded off the tank and off the Coriolis, the micromotion flow meter. I'm gonna go ahead and do the other 3 runs. All right, so we just finished doing our last proof here. And here's our completed table with our start, stop, and all of our mass values for each run there that the meter said. So we'll take that information now and figure out a meter factor. You'll need to figure out the volume, and I'm going to give you a density. So if you have volume and density, you can figure out mass in the tank, and then compare it to the mass that the meter said went through, and figure out a meter factor. All right, so I've taken a sample of the water that we were using to run through our meter here, and I've put this hydrometer into it. It will figure out our specific gravity. I believe if you look, yes, right over here. the scale is in specific gravity, and it was used at a temperature of 60 degrees Fahrenheit. So we're a little bit warmer than that. 60 degrees, about 15 degrees C. We're about 20 degrees C or 21 degrees C at room temperature. So this fluid's probably around 20 degrees C. But anyways, the hydrometer here has a range of 1.000 to the top there. Let's see if I can get it to focus. There we go, 0.9000. So if we look down here, we are sitting, I'm just gonna kind of spin this a little bit. And it stops. It's pretty well right at exactly 1.000. So our relative density, or our specific gravity, which is the same thing, specific gravity is 1.00. So for us to figure out our density of our liquid, of our water, our hygrometer gave us our specific gravity, which was exactly 1.000. And specific gravity is always going to be compared to either water or air at a specified standard condition. And in that case, it was at 60 degrees, right? So for liquids, it's going to be water. And that hydrometer was using 60 degrees for the temperature. So what I did was I looked up the density of water at 60 degrees, and we have it right over here on the board. The density of water at 60 degrees is 999.7 kilograms per meter cubed, or 0.99907 kilograms per liter. So if this is the density of water and our specific gravity was a value of 1, that means the density of our liquid is this exact same value. So this is the density value that we're going to use here to multiply by all of these measurements here that we use to figure out our volume in the vessel. So we're going to use these to figure out volume, then multiply by our density here. If these are in liters, we have to use this. If these are in meters cubed, we have to use this, right? And that will give us, we multiply this by this density, and it will give us the mass of the fluid. And then we can compare it to this mass to get our meter factor. All right, so I've determined the meter factor for this meter here, and I've programmed it in. I've programmed it in for both the mass flow and the volume flow, because it can be the same factor, can be applied to both. And I'm just going to scroll over actually to volume flow, liters per minute here. So we're reading a volume flow of about 14 liters per minute. And what I've done here is I've connected the pump here. I've connected our turbine flow meter in series with our Coriolis, our mass flow meter here. So they're connected in series. So we're setting this up for like a master meter prove now. We've proven this meter, we know that it's working, and now we're comparing it to the flow rate up on this meter. And so you can see that this meter is reading almost the same, it's slightly low. So it would need to be tweaked slightly to make it read the same as our original, the one on the bottom there. So this demonstrates a master meter prove. We're using a master meter, one that we know that it's working, hooking it in series with a meter that we're trying to prove, and verifying that they match. If they don't match, we need to adjust the meter that we're checking. We need to adjust it so that they read the same. So that's all that we need to do for this lab. We did a volumetric prove on our mass flow meter there, entered the meter factors, and then we did a master meter verification with our turbine flow meter that we proved last lab.